in this video, we'll talk about a question such as this question. So then let's see what's this about, right? Okay, so it's asking about pOH. Okay, so I know how to calculate pOH. Let's see what kind of solution we're calculating its pH for. Okay, so now let's keep on reading. We got a concentration at the aqueous solution of ammonium bromide. Okay, so then you go, okay, I'm calculating for ammonium bromide. I'm given Kb value for ammonia. Okay, you go, what's your relationship? Okay, so when I'm looking for a certain substance, I'm given with some information, seems related to, but not exactly what I'm solving for. Okay, so then again, that's something we need to analyze, right? Okay, so now let's look at this substance we're trying to calculate and what is it. Okay, so then you realize, okay, ammonium, that's our one of the polyatomic ion, right? Okay, and then bromide ion, that's how they bonded together by transferring electrons, and we realize this is a ionic compound. Okay, so which means it's a salt. Okay, so okay, you go, oh, okay, now I know I actually have a salt solution. Okay, so then I should also be able to determine even before we start what kind of salt solution this will be. Either it's neutral, acidic, or basic. Okay, so then based on the information we have learned, let's start from bromide ion. Okay, so bromide ion is an anion. Okay, coming from what? Coming from HBr, right? Okay, so then HBr is what? Is a strong acid. If it's a strong acid, and then is anion, or you can call it as conjugate base of this strong acid, right? So it's what? It's gonna be it's gonna be pH neutral. Okay, so it's pH neutral. Okay, so which means we are concerned about pOH or pH if it's neutral, which means it's not gonna affect the pH of our solution, so we don't need to worry about that. Okay, so then let's look at the other part of this salt solution or this ionic compound. Okay, so we have ammonium ion. Okay, so ammonium ion. So that's NH4 class, right? Okay, so how is this related? Or what's this? Where does this come from? Okay, so what is it? It's the conjugate acid of a weak base. What's the weak base? It's ammonia NH3, right? So ammonia itself is a weak base. When it accepts the proton, become what? Become this conjugate acid. This is the cation we're trying to study over here, right? So this is the ammonium ion. Okay, so then again, what's its identity? It's a conjugate acid, right? Okay, so then which is going to make this solution acidic. Okay, so now first thing first, we understand, okay, it's going to be an acidic solution. Okay, so if it's an acidic solution, from the perspective pH, it's going to be what? At 25 degrees C, it should be smaller than 7. But if it's pOH, what we're looking at, the range should be bigger than 7. Okay, so then again, you go, oh, the question is asking us to calculate pOH, so that I know my range, right? My range from what I analyze, right? It should be bigger than 7. Okay, so then let's see how I can calculate that. So then the question will be, okay, ammonium ion, when I have in the aqueous solution, what is it going to do now? Okay, so again, let's work on that. So ammonium ion, right? Since we say it's an acid, so how does acid behave in the aqueous solution, right? What does acid do, right? Use Brasillari definition, it's going to donate a proton. So after it donate a proton, lose a proton, and end up with ammonia. And in this reaction, water will serve as a base. What does base do? Accept a proton, so giving us hydronium ion. And you go, oh, that sounds right. Again, I'm expressing an acid. I'm producing, according to Arrhenius definition, producing hydronium ion. That's good. Okay, so then we also know we're expressing a K. Again, we're expressing an acid, right? Okay, so now we see equilibrium setup. We have equilibrium constant, right? So then we know we need to set up ice table. Okay, so ice table, what's this initial concentration? Since this compound, every one compound giving us one of that ammonium ion, so it's 1-to-N ratio, so the concentration is also 0.2. Okay, so water, right, it's not going to affect our equilibrium constant, and initially had 0 of the product. Okay, so now what's the change? Right, it's going to be negative x at equilibrium, we have 0.2 minus x and x. Okay, so the information at equilibrium, that's what we want to use to solve the problem. Okay, so now I'm going to give us some space. Oops. Okay. I guess I will use the space over here. Okay. So again, right, we are solving for equilibrium, which is Ka. Then you go, oh, wait a minute. I'm given with the information over here. I'm given with the Kb value of this weak base, but I'm trying to solve, right, based off this acid, conjugate acid. So what's the relationship? Now I know, okay, I'm going to put it over here, right? What's the relationship? That Ka times Kb should equal to Kw. Since I know Kb, so I can calculate Ka for my this acid, right? Okay, so then equals to Kw divided by Kb given, which is 1.8 times 10 to the power negative 5. After we solve this, the Ka value turned out to be 5.56 times 10 to the power of negative 10. Okay, so that's the Ka value I just solved, and we try maybe. Okay, so now Ka of this conjugate acid should equals to x times x over 0.2 minus x equals to 5.56 times 10 to the negative 10. Then you realize the Ka value is really small, so we can use small approximation. Since it's the x involving a chain, the chain is so small, so we can ignore it. Okay, so then now solve this x squared equals to 0.2 times 5.56 times 10 to the power negative 10. Take a square root on both sides, as x will be solved as 1.05 times 10 to the power negative 5. Of course, you also should check see if our small approximation is valid by using this x solve divided by the initial concentration 0.2. Then you'll find out it will be smaller than 5%. So we were able to use that small approximation. So this number is okay for us to continue with. Okay, so this x value we solve is the hydronium concentration. Okay, so then from this point, of course, you have two ways to go for solving the pOH for the question. But personally, I like to do pH by taking negative log of hydronium concentration, the number we just solved, plug it in, you will solve this as 4.98. Okay, and then how do we solve pOH? That'll be the relationship is 14, right? 14 minus pH. Then we'll get the value as 9.02. Okay, so then in order to solve the pOH for the salt, the answer is 9.02. Then of course, right, we cannot memorize the process. Sometimes, right, I can simply ask you pH. Then you're gonna stop at 4.98. Then you're done. You didn't have to take an extra step. Again, take it or not depends on if the question asking us or not, right? Okay. So then again, knowing what you're dealing with and how to deal with it, right? Then that's how we're gonna go for, right, how to solve this question. Then as we start off with, we know our pOH should be bigger than 7 by just knowing our cell solution itself. Okay, so then we solve for it, and then it came out as the correct information. Okay, so then that's it. That's the end of this video, and thank you for watching. Hopefully this is helpful.